All right, welcome back everyone to another deep dive. And today, we're going to be looking at a really interesting topic, something that's kind of mysterious to a lot of people, but used all the time.
Hmm.
And that is K-means clustering. Have you heard of that before?
Oh yeah, all the time. I mean, it's a very common method, one of many clustering algorithms. But we're going to be diving deep into it today.
Yeah, and I think a lot of people, maybe they've heard the term, maybe they haven't, but I think everyone has experienced K-means clustering in action in their daily lives, whether they realize it or not.
Yeah.
Like, have you ever wondered how Netflix seems to know exactly what movies you want to watch?
Yeah, recommendation systems, right?
Or how Amazon seems to know exactly what products you might be interested in buying? Or even how banks can detect fraudulent transactions?
Right, right.
Like, all of these things actually often rely on some form of clustering.
Yeah.
And K-means is one of the most, popular and powerful algorithms for doing that.
Absolutely, absolutely. I mean, it's a cornerstone of a lot of machine learning applications. And as you mentioned, it's really about finding patterns and structure in data, and that's what makes it so versatile and so useful.
Yeah. So before we dive into the actual nuts and bolts of how K-means works,
Yeah.
let's take a step back and talk about what clustering is in general.
Right. So, at a very basic level, clustering is about grouping similar things together.
Right.
Whether it's, grouping your socks by color or grouping your books by genre, or in the case of data science, grouping, customers or data points based on shared characteristics or behaviors.
Yep, exactly.
So, the idea is to find these natural groupings or clusters within a data set without, and this is key, without knowing beforehand what those groups should be.
Right. You don't go in with a preconceived notion.
Right. You're letting the data itself reveal the underlying structure. So, how does k-means fit into all of this?
Well, K-means is a particular type of clustering algorithm. And as the name suggests, it's all about finding K clusters in your data.
K being a number. K being a number, yes, that you, the user, or someone with domain knowledge will predefine. So you could be looking for 3 clusters, 5 clusters, 10 clusters, whatever makes sense for the problem you're trying to solve.
Got it. So let's say, for example, we're a clothing retailer, right?
Hmm.
And we want to use K-means to segment our customers. So we might decide that, okay, we want to find, 5 distinct groups of customers based on their purchasing habits.
Hmm.
Maybe there's a group of, bargain hunters, and maybe there's a group of, you know, fashionistas who are always buying the latest trends.
Right, right. Like big spenders, loyal customers, different groups.
Exactly. So how would K-means actually go about finding those 5 groups for us?
So imagine you have all this customer data, right? Who bought what, when they bought it, how much they spent, demographics, all that stuff. K-means it's an iterative process. First, it's going to randomly pick 5 points. Let's say we're using, just 2 dimensions to kind of visualize this. So it picks 5 random points on a graph, and those are your initial cluster centers.
Okay, so it just kind of throws these 5 darts at a board and says, okay, these are my starting points.
Exactly. It's random. And then the algorithm goes through each customer data point, and it measures the distance between that point and each of the 5 cluster centers.
So it's basically saying, okay, which of these 5 points is this customer closest to?
Right. Exactly. And it assigns that customer to the closest cluster. So you can think of it as, drawing lines from each customer to their nearest cluster center, and that's how you start to form these initial clusters.
Got it. But then those initial clusters, based on those randomly chosen points, those might not be the best clusters, right?
Right. That's right. That's where the iterative part comes in. So once you've assigned every customer to a cluster, the algorithm then recalculates the center of each cluster based on, the average position of all the points in that cluster. So the centers themselves move.
Okay, so the clusters are kind of shifting around, they're adjusting, they're becoming more refined.
Precisely. They're becoming more refined, and then you go through the whole process again. So you reassign each customer to the nearest cluster center based on these new positions. You recalculate the centers again, and you keep doing this, iterating, until the cluster centers stop moving or they move very little.
It's like a dance, right?
Yeah.
It's like the data points are kind of shuffling around between the clusters and the centers are kind of adjusting themselves until everything kind of settles into this kind of optimal configuration.
That's a great analogy. That's exactly what's happening. It's a dynamic process. And eventually, it reaches a point where things are pretty stable. You're not seeing a lot of movement. And that's when you can say, okay, we've found our clusters.
That's really cool. I love these kind of analogies because I think it makes it more tangible, for people who might not be familiar with these, mathematical algorithms.
Absolutely. I think analogies are really powerful for kind of grasping these concepts.
Yeah. So we've talked about, how co-means works. We've talked about, how it can be used for things like customer segmentation. But let's dive into some other applications, right? Because this is a really versatile algorithm. So what are some other areas where co-means is being used to solve real-world problems?
Well, I mean, you mentioned recommendations earlier. That's a really big one, right? Netflix, Amazon, Spotify, they're all using some form of clustering to group similar users together and recommend products or content that other users in that group have enjoyed.
Right, right. Because if you and I have very similar taste in movies, and I watch a movie that you haven't seen yet, but I really like it, chances are you might like it too.
Right, and that's how they figure out who to recommend things to. Another big area is image segmentation. So this is where you take an image and you break it down into different regions based on, similarities in color or texture.
Right. So like being able to tell the difference between like a cat and a dog in an image.
Exactly, or a street sign from a pedestrian.
Right.
And this is used in all sorts of applications, from, self-driving cars to medical imaging.
Yeah. It's amazing to think about all the different ways that this kind of clustering can be applied.
hmm
Um, are there any limitations to k-means? Like, are there situations where it's not a good fit?
Oh yeah, definitely. I mean, no algorithm is perfect, right? One of the main limitations of k-means is that it assumes that the clusters are kind of spherical in shape. So if you have data that's, kind of scattered in a weird way, or the clusters are kind of elongated or have, unusual shapes, k-means might not be able to capture that structure very well.
So it's kind of assuming that the data is kind of neatly organized into these kind of roundish clumps.
Right, exactly. And that's not always the case in the real world. Another limitation is that you have to predefine the number of clusters, that K value. And sometimes it's not obvious how many clusters there should be.
Yeah, how do you know if you should be looking for 3, 5, 10?
Right. And there are ways to try to figure that out. There are some statistical methods, some visual methods, but it can be a bit of an art as well as a science.
It's like finding that Goldilocks number,
Yeah.
right? Not too many, not too few, but just right.
Exactly. And if you get that K value wrong, it can really mess up your results.
Interesting. So for our listeners who've been following along and now have better understanding of, what k-means is, what are some of the key takeaways? What do you want them to remember about this algorithm and how it's used in the world?
I mean, I think the main takeaway is that K-means is a really powerful tool for understanding data, for finding patterns, for grouping similar things together. And it's used in so many different applications, from, personalized recommendations to fraud detection to image analysis. But it's important to be aware of its limitations. It's not a magic bullet. It's not going to work perfectly in every situation.
Right. And I think, as we become more and more reliant on, data-driven systems and algorithms, it's really important for us to be more critical consumers of that information.
Right.
Like when you see a report or a visualization based on clustering, don't just take it at face value. Ask yourself, okay, how are those clusters created?
Right.
What assumptions went into that analysis?
Exactly. And maybe even what are the potential biases?
Right.
Because anytime you're grouping things together, you're making choices, you're drawing boundaries, and those choices can have real-world implications.
Absolutely. Well, that wraps up our deep dive into k-means clustering. Thanks for walking us through this fascinating topic. And for our listeners, we'll leave you with this final thought. So we've been talking about grouping similar things together. But what about the power of understanding differences?
Hmm.
What insights might we gain by focusing on the outliers, the data points that don't fit neatly into any cluster? Maybe those are the ones that hold the key to truly groundbreaking discoveries. Thanks for joining us on this deep dive.
Thank you for having me.
We'll see you next time.
See you next time.